Hey guys, welcome back. So we're going to pick up where we left off and work through these practice problems. So we're going to walk through a couple practice problems together. That way you have a chance to do them and see the correct answers. So what we're going to do first is we're going to work on filling in this chart where these blanks are. And then we're going to answer our list of questions over here. So we'll try to keep this short and sweet. Some of the calculations I will speed through because it's either addition or subtraction or multiplication and division. So in those cases, just pause, do the calculations, and check for yourself. So let's get started with this first one. We first need to figure out if it's linear or exponential. So if it's linear, then I should be able to subtract and get the same number every time. If it's not linear, then we'll check for exponential. So we'll start first. 1.51 minus 1.25 will give me 0.26. And then 1.77 minus 1.51 is going to give me 0.26. It's looking linear. 2.03 minus 1.77 will give me, hey, 0.26. So we now know that this is definitely a linear data set. And then which formula did we use? Well, we used the next minus previous, so n minus p. And what was our rule? Well, our rule is that we added, remember, we add to 0.26 each time. And then what are our next three numbers? So we're going to take 2.03 plus 2.6. So to find the next three numbers, we're going to take the last one we were given, so 2.03 plus 0.26, and then that will give us 2.29. So I'll write it up here. And if we keep doing this, we will get 2.55, and then we will get 2.81. All right, so now we have our next three numbers. And so lastly, what's the relationship? So what's that equation look like? So this is the part we probably still need to practice. So since it's linear, it's going to have the form y equals mx plus b. And so remember, our y is going to stay the same. Our m is going to come from our rule, which was part C. So it's going to be equal to 0.26 m. So our m is going to come from part C, which is our rule. So 0.26. Our x is going to stay where it's at. And then our b is going to come from the very first number that we started with. So we're going to start with our 1.25. So down here we will say plus 1.25. So this would be our equation. So let's flip the page and keep going. So number 2, it's the same thing. We're going to be doing the same thing over and over, and this is really just to get you in the practice. So I'm going to move a little bit faster through this one, and so just bear with me. So if we do our subtraction, we will figure out that the subtraction does not work, okay? So if we subtracted each time, we would end up with a series of numbers that looks like this. So this is definitely not linear, so we likely have an exponential, but let's double check that. So let's do the next divided by previous. So I'm not going to write all of these out, but I will write the answers out. So if you do the next divided by previous, you're going to get 1.12 for the first one. And then if you do the next set, you're going to get 1.12. And then for the third, you will also get 1.12. So in this case, we definitely have an exponential data set. And so if that's the case, then we are using the formula n divided by p. And then our rule for this one is going to be times 1.12. And then what are the next three numbers? So if we multiply starting at 2.21 times 1.12, we will get 2.48. And then if we multiply that by 1.12, we will get 2.78. And then if we multiply that by 1.12, we will get 3.11. So those are our next three numbers. So now, what's the relationship? So remember, back in the last video, we said we had y equals x plus b, and that was linear, and then y equals mb to the x was our linear equation. Was our exponential equation. So that's the one we're going to use for part E. So we have y equals mb to the x, and I'm going to put parentheses around my b. And so if we rewrite this with our numbers, we'll have y equals our m, which is our rule, so 1.12, our b, which our b is our first number, so that's going to be this 1.57, and then we'll just close our parentheses and raise it to the x power. And so that is your equation. So the equations take a little bit longer to think about and work through, but really you need your rule and your very first number. All right, so let's move on to the next one. Alrighty, so let's do the same thing one more time. So let's figure out, is it linear or exponential? So if I subtract these two, I get negative 11. If I subtract these two, I get negative 11. And if I subtract the next two, I get negative 11. So this is most definitely linear. All right, so for it's linear, we're going to do next minus previous, or n minus p. And then if we are doing linear, then what is our rule? So our rule we can think of as plus negative 11, which is the same thing as minus 11. So I'm going to write my rule as minus 11. And then what are my next three numbers? So I'm going to keep subtracting off 11. So 65 minus 11 will give me 54. 54 minus 11 will give me 43. And then 43 minus 11 will give me 32. So those are my next three numbers. And then what is my equation? So I mentioned a minute ago that our linear equation looked like y equals mx plus b. It's always our linear equation. If I drop down my y, I need to plug in my m. So remember, m is our c over here, or our rule, I should say that. So negative 11. Our x drops down. And then what is our b? What's the first number we started with? Well, our first number started with 98, so plus 98. And that is our equation. All right, so we've got to the end of these practice problems. And next we're going to move on to slope. So make sure you understand how to do this process, and now we'll talk about applying this process to lines and graphs.